Our presenter today, Mike Peterson, unfortunately couldn't join us. So I'll be giving his pitch about this first-of-its-kind technology coming out of the largest public and private crop editing and transformation facility in the United States. So the team at the WCIC is composed of highly skilled individuals, and together they have worked to develop the world's first transgenic hemp plant. This is a patent-pending technology that has the ability to advance hemp in the ways that the corporate world has seen for other crops like corn and soybean in the past few decades. The team has combined their experience to focus on hemp, which is a notoriously difficult crop to engineer, and that's because it has resistance towards common tissue culture techniques in the lab. But with their new technology, they have the ability to insert novel genes or edit existing genes in the crop. And this allows them to introduce new traits that can provide economic value to growers and new products to consumers. But if this plant is so difficult to work with, why hemp? Why did they decide to focus their efforts on this? Well, the cannabis market, and hemp is a species of cannabis, is a multi-billion-dollar market. But until recently, it had been subject to over 80 years of negative federal regulations. Those regulations made it nearly impossible for teams like the WCIC to make any significant advances in the cannabis space. But cannabis has over 50,000 uses, from anything from like textiles, clothing, food, building materials, and medical applications, just to name a few. And so with their technology, with genetic engineering and editing, they have the ability to open new opportunities by introducing new traits that can capture huge value in the market. For example, their technology has been shown to increase fiber biomass and yield. And this is important because there are big companies like Patagonia and Nike who are using hemp fiber to make their clothes and their shoes. There are other companies who are looking at using hemp to make carbon-negative building materials like hempcrete. Hemp itself has the ability to capture over 2 times the amount of CO2 from the air than trees can. And because of that, it will likely become a go-to crop for carbon credits. And so as industry ramps up its demand and its interest in using hemp fiber, genetic engineering will be called upon to keep up with this demand by creating these crops that have this individual trait for increased yield. Another space in which this technology can have a lot of impact is that of the cannabinoids. In particular, this technology has the ability to increase or change the ratio of specific cannabinoids in the plant. So we all know about CBD and its potential benefits and uses, but there are over 100 other types of cannabinoids, more rare and potentially more valuable cannabinoids in hemp. For example, CBG is being looked at by the pharmaceutical industry for its potential medical benefits. It has 25 times the value of CBD, but it's produced in significantly lower quantities. And so with this tech, the WCIC team can ramp up the amounts of CBG or other potentially valuable cannabinoids in hemp to create value. Furthermore, this technology has the ability to customize or increase the amounts of key components in hemp to create new opportunities in the medical and the fragrance industries. These key components that I'm talking about are aromatic compounds known as terpenes that give hemp its flavor and odor. Now, these terpenes are produced in minute quantities in the plant, but they're still being explored for their medical benefits. And combinations of terpenes can be used to create fragrances. And so with this tech, customized terpene profiles or increased levels of specific terpenes can be induced in the plant to create high-value lines. So as I mentioned earlier, this team has extensive experience. They've worked with both public and private clients in the US and abroad. And the team consists of Mike Peterson, who couldn't be here today, a senior scientist at the WCIC and an inventor on this technology, Sean Kepler, who's the director of the WCIC, a crop breeder and a co-inventor for this tech, and Shelby Ellison, who's an assistant professor of horticulture at UW-Madison, whose research program focuses on hemp genetics and breeding. She's also the point person for UW's industrial hemp and research education. Now, this technology has received traction so far. The team has been able to apply the methodology to create proof of concept plants that can express a red fluorescent gene. And they have been working with industry clients, Hypercan and Zcal, to find traits of interest that can boost their product pipeline. Additionally, they're focusing on addressing the needs of cannabis producers by controlling the cannabinoid production and have successfully developed plantlets that can target specific individual traits. For example, they have developed a zero THC line, increased CBG line, and a line with increased trichomes. And they have received over $2 million of funding to date from various sources such as the Erdman Family Farms, USDA, and WARF. And all of this money is going to help further develop this patent-pending technology and introduce value-added traits into hemp. But there are numerous other traits that this methodology can be applied to. Traits like disease and drought resistance, seed resiliency, fiber output, growth habits, and more. And so the team is looking to find industry partners to work with them to identify traits of interest for commercial cannabis growers. And also they're looking for collaborators to work with them and the UW-Madison to help grow and commercialize hemp for the global industrial hemp market. So thanks so much for listening to me give someone else's pitch today. If you have any questions about this technology, please feel free to email Mike, or you can feel free to email me or anybody at WARF, and we'll help put you in contact with the WCIC team.